In this week's assignment, you're going to be looking at a network that depicts a karate club. So this karate club existed in the 1970s, and as you'll read in the paper, written by Zachary, you will find out kind of what was causing conflict in the club and what the fallout of that conflict was when it actually came to a head. It's a little bit different this week. You're going to read the paper that's provided here, and so you'll need this to answer a lot of the questions that are in the accompanying quiz. If you like, you can also get this from the West Texas A&M Library online. There is no separate PDF of instructions for this assignment. So what you'll do is first you will download and read the paper that describes the nature of the Karate Club network. The next thing you'll do is download and run the Python code that I've provided to you. So let's take a look at what that looks like. So I'm just going to copy it and then paste it in Atom or whatever it is that you're using. You will then run the code. And to give you a brief walkthrough of what's going on here, what you're going to look at are three different visualizations. So the first visualization will be that of the actual Karate Club network. So this network is so famous that Network X actually has a copy of it built in. So these lines right here, 20 through 25, this is going to be generating the Karate Club network and then also creating a visualization for it, similar to how we did in the first assignment that we used Python. So here again, the only things that you'll have to change are the paths. So every time there's a figure that gets saved, you'll have to go in and put in your own path on your own computer so that you can then find the visualizations. So after being able to see what the original network looks like, the next thing that you'll do is generate a visualization of what happened after the club actually split up. So this is ground truth data about what actually happened. And what it will do is it will color code the different factions, which again, you'll read about in the paper, red and blue. And so you'll be able to see exactly how the club was split up by color after you run this part. And so this part will actually break the club up into its factions by color. So you'll have one red grouping and one blue grouping. And you'll be able to see color-coded what the network looked like after the split. So this is lines 27 through 38. Finally, what you'll do is use one algorithm, which is a Girvan-Newman algorithm. And this is an algorithm that is predictive. So you give it a network, and it will predict based on the network structure if there were to be a split, what that split would look like. So this last visualization that you'll create will show you the predicted network split by color. Again, you'll have red and blue, and you'll be able to compare the prediction of this algorithm to the actual split in the network. So again, this Girvan-Newman algorithm, lines 40 through 49. When you are finished reading the article and running the code, you'll then go ahead and complete the quiz for the assignment. And so similarly, you'll have a question about what each line of code does. You'll have to answer a couple of questions about output from Atom, and it should specify whether or not you're getting your answer from your code or from the paper. You'll also have a couple of questions that are related to the paper, and so you'll have to kind of read it in order to understand what's going on there. In question 7, I'm looking for the terminology that applies to the network before any analysis takes place. So you can disregard the analysis parts when you're thinking about this question. So you'll have to use both resources, the paper as well as the output from running the Python code in order to complete this quiz. So it should be pretty straightforward. So if you have any questions about the instructions or have issues with Python, again, just let me know. send me a screenshot and we'll see if we can figure it out. Good luck.